Today topic is enthalpy and enthalpy change. Okay, so enthalpy and enthalpy change. You know what is the definition of change in internal energy? It is, yes, it is heat energy exchanged. Very good. Heat energy exchanged between system and surrounding at constant volumes and temperature. Okay. So, it is very difficult to keep the volume constant. Say, when we do the reaction in labs, we have test tube, and test tube is open, chemical reaction is taking place and it is open, right? So, most of the reaction which we are carrying out are in the open container. Okay, even all the natural reactions, there is no like we have closed it in a specified volume. Okay, that is under atmospheric pressure. Okay, so that means internal energy or change in internal energy, it is specific term which is used when volume is kept constant. But in most of the cases, volume is not constant, but pressure is constant because they are under atmospheric pressure, or which is constant in a particular place. Okay, that's why what we do, we can take the next level of heat exchange. When heat is exchanged between system and surroundings at constant pressure and temperature is known as heat. Simply write heat exchanged between system and surrounding, okay, is known as change in enthalpy. See, what is the basic difference? Here we use constant pressure, and in case of, means in enthalpy, we kept pressure constant, and in case of internal energy, we kept volume constant. Okay, if heat exchange is between system and surrounding at constant volume, then it is change in internal energy, and if it is at constant pressure, that is called change in enthalpy. And change in enthalpy is most common term. Okay, so that means when pressure is constant, volume can be increased or can be decreased, right? Volume can be increased or decreased. So tell me, volume, if it increases, then what it means? During the chemical process, if volume is increased, what it means? Work is done by the system or on the system? Yes. During chemical or physical process, if volume is increased, then work is done. Volume is increased, beta. See, volume is increased. So work is done by the system. आई थिंक आप फिजिक्स पढ़ के आए हो, इसलिए आपको कंफ्यूजन हो रहा है. Say there is the volume V1. Now volume is changed into V2. So V2 is greater than V1. Okay, that means delta V is V2 minus V1, that is positive. So when volume is increased, that means work is done by the system. And if volume is decreased, see, initial volume is V1 and now V2, that means volume is decreased. So it is work is done by the surrounding on the system. So when volume is decreased, then work is done on the system. The volume is increased means it is expansion work. So expansion work means work is done by the system. Simple beta, identification is very, very simple. See, expansion work. Expansion work means volume is increased. So when volume is increased, work is done by the system. Means expansion work is work done by the system. Okay, when work is done by the system, that means energy of the system is consumed. Then what happens to its internal energy? Yes, then its internal energy beta, internal energy decreases because system does the work. When system does the work, then energy of the system is consumed. So energy, total energy of the system decreases because we apply law of conservation of energy, first law of thermodynamics, right? So internal energy decreases. Now compression work. Compression work means what happened? Volume is decreased. Okay, so volume is decreased, so work is done on the system, and its internal energy yes, because now work is done on the system. So that means energy content of the system is increased. So internal energy increases. Okay. Got these two terms? Internal energy and pressure volume work. When volume is not constant. Here pressure is constant, okay. So in addition to the internal energy, there is a change in pressure volume work. So now this H means enthalpy is equal to internal energy plus pressure volume work. Means pressure volume energy. say pressure volume is also energy, because you know pressure into volume means force per unit area, volume is area into length. So area cancel means force into length means force into distance. So force into distance means energy or work, right? So enthalpy H is equal to internal energy means sum of the internal energy and pressure volume energy. Okay. So change in, whenever there is a constant pressure, the term is known as enthalpy. Okay. So heat content is enthalpy. So what is the difference between enthalpy and internal energy? I think you have an idea now. Okay. So H is equal to U plus PV. Sometime U is replaced by E in many books. So it's okay, right? Now enthalpy as well as internal energy both are state functions. H and U both are state functions. Yes, tell me what is state function? I think it is very difficult to write for you to type actually the mobile, but try. Yes, tell me, what do you mean by state function? So what is state function? Very good. They depend on state of the system. Very good. And are independent of, yes, and are very good, and does not depend on the path followed. Very good. And are independent of the path followed or independent of the manner by which the state has been attained. Or you can simply write independent of the path followed. That's right, very good. So keep in mind both internal energy and enthalpy are state functions. They do not depend on the path followed to attain that state. It depends on the state only, right? Okay. Now if question is derive the relation delta H equal to delta U plus P delta V, or delta H equal to delta U plus delta Mg RT. Out of these two, if there is any question, then same derive the relation delta H equal to delta U plus delta P delta V, or delta H equal to delta U plus delta Mg RT. Okay. So you know, if we have dealt with H, then what we kept constant? What we keep constant? Namita, it's okay. Yes, tell me. So this is the question and I am writing the answer. Okay. Whatever you have to write in your means board exam, means class 11th exam. Okay. Okay. It can be question like derive the relation between delta H and delta U. Simply question, derive the relation between delta H and delta U. It can be asked in any way. Okay. So let us consider a reaction. We start with, let us consider a chemical reaction, okay, taking place at constant pressure and temperature. Keep in mind pressure and temperature. Okay. So reaction, let us take the reaction as A to give B. Okay. A is reactant and B is product, or you can write R and P, whatever you wish to write. Okay. And let us suppose HA and HB are enthalpies of reactants and products respectively. Okay. UA and UB are internal energies of reactants and products respectively. Okay. And VA and VB, volume of reactants and products respectively. Okay. Now, first, what is the relation between H and U? So we start with, since H is equal to U plus PB, therefore HA is equal to UA plus PBA for reactants, okay, and for products HB equal to UB plus PBB, because pressure is constant and you can write P is pressure. Okay, P is pressure, that is constant. Okay, pressure of the reaction mixture, and this pressure is constant. T is temperature, that is also constant. Yes, we can do that part beta, but to derive the next relation, okay, for the first relation we have to use this relation only, that H equal to U plus PV. Okay. Now, what is the change in enthalpy? Change in enthalpy delta H, okay, that is equal to, yes, tell me, that is enthalpy of the product minus enthalpy of the reactant. Enthalpy of the product minus enthalpy of the reactant, right? And this change in enthalpy is the heat energy exchange between the system and surrounding at constant pressure and temperature. Okay. So HB minus HA means enthalpy of the product minus enthalpy of the reactant. So UB plus PVB minus UA plus PVA, right? So that is equal to UB minus UA plus P is common, that is VB minus VA. Okay. So in this way, delta UB minus UA, you know, that is delta U is enthalpy of the internal energy of the product minus internal energy of the reactant, and delta V, that is equal to volume of the product minus volume of the reactant. This is change in internal energy, and delta V is change in volume. So just put the values. This is delta H. So delta H is equal to delta U plus P delta V. That's it. So derive the relation. Okay. That means change in enthalpy is equal to, yes, change in enthalpy. So what is change in enthalpy of a system? Change in enthalpy of the system is, yes, the sum of change in internal energy this, okay, sum of change in internal energy and energy as pressure volume work. This is pressure volume work, okay, right? So change value of delta H can be calculated if we know delta U and P delta V. That means delta V, change in volume, that is significant only in gaseous reactions, you know, because volume change takes place only when there is a gaseous reactant or products. Okay, because if there is a solid and liquid only, is there any change in significant change in volume? No. Delta V is almost 0. Okay, and but it is you know, it is not very, we are not comfortable to calculate the exact change in volume involving gases, right? So what we do, we use ideal gas equation. Okay, what we use, ideal gas equation. So keep in mind, whenever we have, see, this is the relation, delta H equal to delta U plus P delta V. So this relation is used when there are gaseous, you know, if we have solids and liquids only, then delta V is almost 0. So that means it is used for gaseous systems. Okay, but at the same time, exact change in volume, it is very difficult to calculate. Exact change in volume is not possible to calculate even for gaseous mixture. That's why what we do, we change it into change in number of gaseous moles. That is easier to calculate. So now we proceed further. Let me start from here only. See, we have derived this relation delta H equal to delta U plus P delta V. So, according to ideal gas equation, PV equal to nRT. PV equal to nRT. So, let us consider that nR is the number of gaseous moles of reactants and Np as number of gaseous moles of products. Keep in mind only gaseous moles, because we are using ideal gas equation. Okay, so only gaseous moles are counted. So P into V, what we have written, A. So PVA is equal to nRT. PV equal to nRT. So volume, it is for reactants, and PVB is equal to nPRT, that is for products. Only we have to count only gaseous reactants or gaseous products. Keep in mind. Now, so P delta V is equal to P into VB minus VA, that is PVB minus PVA. So it is equal to nPRT minus nRT. So RT is common, so it is nP minus nRT. So just replace P delta V by this relation. Okay. So now this relation delta H equal to delta U plus P delta V is changed into delta U plus Np minus Nr RT, where capital R, it is a gas constant. So Np minus Nr is equal to delta Ng. So delta Ng means number of gaseous moles of products minus number of gaseous moles of reactants. Okay, that means it is a change in gaseous moles. It is change in gaseous moles. Okay, that is change in gaseous moles. So relation become delta H equal to delta U plus delta Ng RT. Okay, delta H is change in enthalpy, delta U change in internal energy, delta Ng change in gaseous moles of reactants or products, and what is R? R is gas constant. And what is T? Its value is, generally we have taken 8.314 joule per Kelvin per mole, because in thermodynamics we deal with enthalpy. Okay. And what is T? Yes, what is T? That is temperature in Kelvin. Okay. So in this way we have derived these equations. Now if we have a reaction, let us take calcium carbonate solid, okay, to give calcium oxide solid, CO2 gas. So tell me what is delta Ng for it? Carbon solid plus O2 gas to CO2 gas. Yes, what is delta Ng? You can start with H equal to U plus nRT. Instead of PV, you can start with PV H equal to U plus nRT. According to ideal gas equation, PV equal to nRT. So you can write it like this and carry out the whole derivation. Skip that part. You can take H, then you can write it like this. UP plus NP RT. Okay. So delta H equal to HP minus HR. So UP plus NP RT minus UR plus NR RT. Okay. So it becomes UP minus UR, right, plus NP minus NR into RT. Okay. So it becomes delta U plus delta Ng RT. That's it. Okay, Ralam. You can go like this. First write according to ideal gas equation, PV equal to nRT. Okay, and go like this. Yes, tell me beta, what is delta Ng for the first reaction, second reaction and third reaction? Fast. Sumit Goel, I am going deeply, don't worry. Tell me what is delta Ng? Where are all? Vadehi, Mansi, Anika, Sakshi, Abhijit. Where are you all? Just reply. Namita. Is there a Chitra today? Chitra present? Yes, tell me what is delta Ng for the first reaction, second reaction and third reaction? Delta Ng is number of gaseous moles of product minus reactant. So here gaseous moles are 2 in the product and in the reactant there is 1. So, value comes out to be 1. That means delta Ng is greater than 0, means delta Ng is positive. So, delta H is greater than delta U. Delta H is greater than delta U because delta Ng is positive. What about the first one? I am specifically interested in second. What is delta Ng in the second reaction? वो सो गए हो सारे? एक तो ये 10 लोग देख रहे हैं, लाइक 8 ही हैं, क्यों ऐसा है? लाइक कर दो वीडियो को पहले और बोलो आंसर प्लीज फास्ट. संकल्प, हाय बेटा, बोलो यार डेल्टा एन जी की वैल्यू. रेली मैं तो इरिटेट हो रहा हूँ यार, आप लोग नहीं पता चला बेटा? बेटा देखो यहां पे रिएक्शन में देखो CO2 कितना है, 1 मोल, कैल्शियम ऑक्साइड भी 1 मोल, बट हमें सिर्फ गैशियस मोल काउंट करने हैं. तो 1 कार्बन डाइऑक्साइड है ना, तो 1 हो गया प्रोडक्ट का मोल, और रिएक्टेंट साइड सिर्फ सॉलिड है, गैस है ही नहीं, तो 0 मीन्स डेल्टा एन जी इज 1. समझे नहीं मानसी? गॉट इट? So I will quote many examples. First, Chitra, for the second one, say in the product, how many gaseous moles are there? The gaseous moles is 1. Means you should count this coefficient. Stoichiometric coefficient. Okay, that is in moles. So 1 in the reactant, you know, carbon is solid, so that is not counted towards the number of gaseous moles, only O2. So O2 there is 1 mole, so 1 minus 1 0. So in this case delta H is equal to delta U. In this case delta H is greater than delta U. I think you got it now, right? हाँ, second case में 0. Now tell me, if we have N2 gas plus 3H2 gas to give 2NH3 gas. Yes, tell me, what is delta Ng in this case? All of you should answer. Even if anybody answered, you should answer it. Yes. All of you, I need answer from each one of you. All the 10 people who are watching. Wrong, Ralam. Answer is wrong. Because sign matters a lot in thermodynamics. Keep in mind, sign sign matters a lot. Very good, Abhay. It is -2. It is -2, beta, not 2. Chitra, Sakshi, beta, sign matters a lot in it. It is product minus reactant. So, how many moles of product are there? And how many moles of reactant are there? Yes, it is -2. Abhishek Sahu, where are you? Beta, delta Ng, I am repeating it once again, number of gaseous moles of product minus number of gaseous moles of reactant. So, if you talk about product, there are 2 gaseous moles. If for reactant, 1 mole of nitrogen gas plus 3 moles of hydrogen gas, total 4. Yes, so delta Ng equal to 2 minus 4, so it is -2. That means delta Ng is negative. So, delta H is less than delta U. Yes, right. It is -2 and delta H is less than delta U. Okay. Very good. I think all of you are comfortable with it now. How do we calculate delta Ng? Are you comfortable now? Or you need more examples? Okay, great. Now, next part, or let us do one question related to it. Okay, let's do one question. Let's take NCERT question, solved question. Okay. Okay, question is, if water vapor is assumed to be a perfect gas, molar enthalpy change of vaporization, molar enthalpy change of vaporization of 1 mole of water at 1 bar pressure and 100 degrees Celsius is 41 kilojoule per mole. So, calculate the internal energy change when first is 1 mole of water is vaporized. At 1 bar and at 100 degree Celsius. Or second is opposite, 1 mole of water is converted into ice. Yes, do it. In first case, 1 mole of water is vaporized, okay, at 1 bar pressure and 100 degree Celsius. Perfect gas means ideal gas. Good evening, Aryan Parmar. Oh my God, time is over, beta. Sorry, Siddharth, you should remind me before writing the question. But anyhow, you can watch it later, beta. I will solve this example only and then I will sign off. Okay? Yes, do it. So let's do first one. Saurabh, tell me, what is one, Saurabh Sarkar? Say, for the vaporization of 1 mole of water, that means H2O liquid to H2O gas. Am I right? Now, for this vaporization, delta H is, it is given because enthalpy of vaporization means when 1 mole of H2O liquid is converted into H2O water, H2O gas. Very good, Namita, very good. Delta H is given. What is delta Ng? Product gaseous moles are 1, reactant gaseous moles 0, so it is 1. Delta Ng is 1. And what about R? R is 8.314 joule per Kelvin per mole. And what is temperature? Temperature should be in Kelvin. So 100 plus 273, that is 373 Kelvin. Okay. So just put the values. Delta H is equal to delta U plus delta Ng RT. That implies delta U equal to delta H minus delta Ng RT. So, okay, Saurabh, you have written that delta Ng is 1. Very good, beta. So, it is 41. It is in kilojoule per mole. Minus, what is delta Ng? 1 mole into R. So, R should be in kilojoule. So, it is 8.314 into 10 raised to power minus 3 kilojoule per Kelvin per mole into 373 Kelvin. Good, beta. So 41 minus this value comes out to be on solving 3.1. So keep in mind, we have to convert the given values in kilojoule. So it is kilojoule delta U, delta 37.9 kilojoule per mole. because H2O liquid is converted into H2O gas. Okay. Now in second case, what we are doing? We are converting H2O liquid into ice, that is H2O solid. So what is delta Ng? Delta Ng is 0 because no gaseous mole is present as a reactant or product. So delta U, that is delta H minus delta Ng RT, that is equal to delta H minus 0 RT. So that is simply equal to delta H, and that is 41 kilojoule per mole. That's it. Okay. So thank you so much for watching this video. Do like, yes, you have liked, already liked, okay, and do subscribe the channel. God bless you all. Happy learning. Jai Hind, Jai Bharat.